Nigerian Genius.
Good evening, guys. This is Nigerian Genius once again. We are currently reporting our daily progress report for the evening. So how did our day actually go? We didn't sleep throughout last night, and we're actually frustrated this morning because what we worked on, what we said we work on last night, which was the connections and the programming and stuff, were giving us a bit of tough challenges. But nevertheless, we pulled through that morning because immediately day was bright and it was 9 o'clock a.m. It was the presentation and the report of your past and current progress and your future plans, which we did wonderfully. We explained our challenges to the judges and also expressed our low confidence concerning our current challenges.
We already wrote all the codes to be sent into the Arduino board before. But when it came now, we then discovered that for it to have remote access and control, instead of using the Arduino board, we are going to be using the camera, the module, the ESP32 camera module, and downloading the software to send this stuff to ESP32 camera module is proving to be difficult.
An awesome time here. Yes, this morning we got to have our progress report where we talked to our mentors, we told them how far we've come, our challenges, and what we aim to do today.
We're able to display our live chat app system and how our UIs and app interfaces was working for both the doctor and the mobile app interfaces, which our mentors commended us for the advancement and improvement, and told us that we should go ahead with our development.
And by the grace of God, we've been able to do most of what we aimed to do today. So we've been working all day long. It's really been tense.
This is Team SH Footmina, and today is day 5 at the Nigerian Genius competition. Today we had our presentations in the morning as usual, and we talked on how our progress that from yesterday up to today, how it went, and we also talked about what were our next plans for today and how it's going to go, our going work, our activities for today.
We got our materials and we started working with what we had yesterday. We assembled some of the structures like the motor and the mechanisms. So we started looking at each and every component that is accessible and matching them to their various physical components. So we did that arrangement. Today we are hoping on getting the main components, that is the materials which we ordered for, and we are planning on making at least a whole assembly, everything together on the board.
One of our challenges we had yesterday was our hardware and software components. We didn't have them to start our own build because of the deadline is very small and the time we have is tight. So we actually got our our hardware today. The one we placed order for, we actually had the hardware today. And today, as you can see, we started working on our prototype. Yes. So the device we are building is a medical device that is capable of monitoring patients and give vital information back to the doctor wirelessly.
Hello everyone, this is Team ART for Milio. For today being D5 at the NCI Innovation Center, we have been able to achieve in the morning our daily progress reports, where we told the judges our daily routine, what we did yesterday and what we are going to do today.
The circuit, simulating the circuit that was in front of her, and unfortunately she short circuit in the system, and we are still looking for a way to solve that issue.
That aside, after the progress reports, we went into our cubicles where we continue to tackle these challenges of programming and control, giving the device remote control and access. But aside that, we sent our project, or we sent a prototype of our project to the 3D printer today, and this is how it's supposed to look like. It's supposed to be a sphere, but this is just a prototype, so we know how the device will fit in inside. So now, if we happen to be able to tackle with these coding and programming challenges, we'll be able to scale up a big 3D size that can fit in all these components. And because of we 3D printed this now, we'll be able to know that a square surface can't fit in properly in a cylindrical or a curvature. Now you might be wondering, what is this sphere ball? Now, the name of our device is called an health sphere, a device that operates as a mini hospital. It's one of the latest future inventions. I'll call it a future invention because before we chose to design this device, we looked on the internet and made sure that no other person has designed something like this before. Of course, you have seen vitality science machine that require you touching them. For example, the blood pressure machine that requires you pumping, wearing a cast around the hand and pumping, or the thermometer that requires you touching to read your temperature. But this device we are building now will give you your readings without touching your temperature. For example, if you happen to walk into this room and the device just catches your face for, let's say, 1 or 2 seconds, it can be able to tell you your blood pressure, your heartbeat, your pulse rate, and your pain level just with the temperature of your current body. Now, what we're using for this device is the MLX 90614 sensor, and the ESP32 cam.
Our mentors came to each each cubicle rather. So when they came to our cubicle, we explained what we are doing and how far we've come. So we demonstrated our hardware and also our software to them as well, and they were quite impressed with what we are doing. So as for what we are doing, I will start by telling you guys the task we were given. So we were given the task of developing a medical device that has remote access and control to mitigate the effects of shortage in health practitioners that we have in our country. So we thought about it. It took us a long time to come up with an idea. So during our brainstorming session, we saw two major problems, and one of those problems were access to the doctors, as well as the link between the doctor and the patient. And another problem we thought of solving, which we saw, was the problem of patient detail during emergency situations. So we came up with an idea to solve that problem using already existing practices, right? So we, instead of coming up with something that is quite different from what we knew, we thought of doing it in a way that users can integrate it to their daily life, and also it doesn't make much difference into their dressing and all that. Of a smartwatch, but instead of just showing you those values like what the conventional smartwatch does, showing you your heart rate, temperature, and all those values that it does, as it shows you those values on the screen, the doctor can actually view those values via his desktop app, which we've built. So remotely, the doctor can interact with your health conditions. So that bridges that link between the doctor and the patient. Secondly, when we have an emergency button, so if there's a case of emergency, possibly an accident on any of our users, anyone that uses our device, there's an accident for instance, and that person is rushed to a hospital. So instead of undergoing that process of running tests to get the genotype, blood group, weight, height, and all that, which usually takes 30 minutes to 1 hour, once you just press that button, it automatically sends your data from which you have saved on the database, genotype, height, weight, all those data, to the hospital's email address. So it makes it faster for the doctor to start implementing treatment in emergency situations. So far we've been able to finish both our mobile app, our desktop app, running perfectly well. We also are trying to assemble our hardware, which you can see here. So our hardware is coming through, and we've been able to integrate our sensors as well and tested them, and they're working fine. So hopefully by the end of today, we'll be done with the hardware assembly and also integrated the hardware with the database and see how it communicates with both the mobile app and desktop app.
The device we are building is capable of sending vital information about a patient to the doctor or the nurse or any hospital personnel that is around that particular area. So what it's going to do is it's going to send the heart rates of a patient. It's going to send the heart rate status of the patient to the doctor. It's also going to send the temperature details of the patient to the doctor. And another tech we are incorporating in the device is a monitoring drip system. We notice that most of the times in hospitals, when patients are given these drip systems, they are not the hospital personnel, the doctor or the nurses are not always around to monitor them. So we are looking for a way to put a monitoring system that is automatic, so that when the drip gets finished, it can actually cut off the tube system. And so what we're trying to do is to hold down the atmospheric pressure from going back up, because we don't want the blood from the patient to start going back up since it's actually on the vein. So we're trying to look for a mechanism using a servo that can actually grip the tubing. So by gripping it, we're going to seal it and stop the blood or whatever is between the grip and the patient's body. We're going to stop the atmospheric pressure from going back up. So that's the major feature of this device. And then from there, we are also looking on how we can also send those information that this drip system will it has the whole steam is empty